Hi again. So this is about line balancing. We are trying to understand how to design the workstations and the number of workstations needed. So usually the problem is given in this way. So what are the different tasks associated with it and what are the immediate predecessors that we have in that particular task and the time taken for each task. And please note the time is in minutes over here. And one more point is like, okay, using that information, we need to draw the precedence diagram. So, and there are a few other points also to consider, and we'll go one after another. So first thing, task A is independent. There is no predecessor to it. And there is task B, which is dependent on A. Task B, which is dependent on A. And there is another task, independent task C. And there is a task which is dependent on C, which is D. And E is dependent on B. And F depends upon D and E. G depends upon F and H depends upon H. So using this one, when we put the precedence diagram with all the formula, 0.2, sorry, C is 0.8, D is 0.6, E is 0.3. E is 0.3, F is 1.0, H is 0.4, sorry, G is 0.4 and H is 0.3. This is example 2 in page number 275, this question for your reference. So when it comes to the total time, this is 3.8 minutes. Now, there are a few concepts that we wanted to understand. One is cycle time. So cycle time as per this precedence diagram is the maximum time taken at any particular task. Out of all these things, the maximum time that is taken is 1 minute. So as per this, it is 1 minute. So the cycle time indicates the time within which the next product comes out of that particular assembly or manufacturing line. So every 1 minute, the next product comes out. And one more point is throughput time. So to throughput time, we need to add along with the all the time that is taken, like 0.2 plus 0.2 plus 0.3 plus 1 plus 0.4 plus 0.3. That is one way. So we do have 0.7, 1.7, 2, 2.4. So 2.4 minutes in one line, and second line is 0.8 plus 0.6. Few 0.1 minute. So considering this, the maximum of these two paths is the throughput time. Here, throughput time is 3.1 minutes. What does it indicate? For the very first product to come out of that assembly line or the manufacturing line, it takes minimum of 3.1 minutes after completing this entire thing. We are assuming these are two parallel lines. So the maximum time taken out of this line and the maximum time taken out of this line. So we will consider that, and that becomes our throughput time. So to reiterate, in 3.1 minutes, the very first product comes out of that particular line. Followed by that, every 1 minute, there is a new product that comes out. So this is 1 minute is the cycle time, and 3.1 minutes is the throughput time, and the total time taken is 3.8 minutes. Okay, and Another point to consider is like we do have 8-hour workday and 400 units per day. So based on this information also we can calculate the cycle time. This is according to our demand. So 8 into 60 because it is in hours and we need to convert it into minutes divided by 400 is equal to 1.2 minutes. Sorry. So again, out of these two lines, 1.2 minutes and 1 minute, we have to consider the maximum value for the cycle time. So if our demand is such that if every product comes out of the machine in 1.2 minutes, that is enough for us. So why to exhaust and bring the next product out in 1 minute? So we go along with the demand. So in this particular example, the cycle time to be considered is 1.2 minutes. Now we are going to check based on this information, we are going to check the number of workstations. So number of workstations equal to total time, that is 3.8 minutes, divided by cycle time, which is 1.2 minutes. Please make sure that both of them are in the same units. So which is equivalent to 3.17 stations. We cannot have 3.17 stations, so we round it off to next big number, that is equal to 4 workstations. So the way we arrange them will be in such a way that this gives an indication, a rough indication that we would be in need of 4 workstations. And followed by that, now we have to design the time taken for this. Let me draw this diagram one more time below, or maybe I'll just zoom out. So here we are going to take the just give me 1 minute. So A followed by B followed by C and C followed by D. Okay. H. So now we are designing workstation 1. So now we are designing workstation, and according to us, the cycle time is 1.2 minutes. So let us start with A. We can start with any one of them, A or C. And we can start with A. For A, it takes 0.2 minutes. And we do have a 1.2 minutes as our cycle time. So the balance remaining is 1 minute. Now this becomes our next input. So the available time over here is 1 minute. We are considering, let's say, B. We can consider any one of them. So we consider B, which takes 0.2 minutes. The time remaining is 1 minute. So 1 minus 0.2 is 0.8 minutes is the remaining. Now we can consider E or we can consider C. So if we consider C, C takes 0.8 minutes and the balance remaining is 0.8 minutes. So over here balance remaining is 0. So with this one, we can design workstation 1 with A, B and C together. Now workstation 2. we can go ahead with E or D because that is the next best alternative that we can think of. Let us start with E, which takes 0.3 and our cycle time is 1.2 minutes and the remaining time is 0.9 minutes, followed by D, which is 0.6 minutes and the available time is 0.9, so the balance is 0.3 minutes. In 0.3 minutes, we cannot fit in F, so we just leave it to be. So this is our idle time. Workstation 3 is F to start with, which takes 1 minute and the available time is 0.2 minutes and the balance is 1.2 idle time. Since we cannot fit in G, this becomes the idle time. Now workstation 4 starts with G, which takes 0.4 minutes. Cycle time available is 1.2. The remaining is 0.8. H takes 0.3 minutes. Available time is 0.8. Balance is 0.5 minutes, which is our idle time. So here, here, and here. So the total idle time we are going to calculate 0 plus 0.3 plus 0.2 plus 0.5, which is equal to 1 minute. So the total idle time is 1 minute after designing all these things. So now based on this workstation designing, what we can consider here is A, B, and C are part of one workstation. E and D are part of another workstation. F alone is in one workstation. And G and H are as part of another workstation. So this is what we can, this is what the design that we can give as part of our workstations. Now coming to the idle time, using this idle time, we can actually calculate the efficiency. So this efficiency is calculated by 100 minus the percentage of idle time. So 100 minus percentage of idle time. And this idle time is nothing but total idle time 1 divided by number of workstations 4 multiplied by cycle time, which is 1.2 minutes. This is into 100, of course, which is 20.83%. So 100 minus 20.83, which is equivalent to 79.17%. This is our efficiency. So we do totally have 4 workstations. Each one is taking 1.2 minutes of cycle time, and out of all that, we do have 1 minute as our total idle time. So this is the percentage of idle time, which when we subtract it from 100, that gives our efficiency. And coming to few other concepts, like how to give this precedence. Like, in this example, I have simply taken the order of the design A, B, E, C, D, and F, G, H based on the precedence. But it may even happen that it would be told us to consider the maximum number of, like in case of any tie, whether to consider A or B, which task or which task to consider next. In case of any tie, the tiebreakers can be mentioned in the problem itself. For example, now I am skeptical about to start with itself. I can take either A task or C task. So if it is mentioned that in case of a tie, let us consider the task which is taking maximum time has to be given preference. Then we have to consider C first. C followed by D because it takes even more time. So that's how it goes. Which task is giving more, which task is taking more time. and then followed by A, B, and then E. So this might become one particular workstation, and this may become another workstation, and so on and so forth. By giving these preferences, sometimes the number of workstations can be more than the number of workstations that we might calculate over here. Using the formula, we are getting only 4 minutes. But if we start giving precedence to the task that is taking more time, we might end up having 5 workstations also. And another tiebreaker could be number of tasks in the more the tasks that are preceding. Like in case of A and C, A has 1, 2, 3, 4, 5 tasks afterwards, whereas C has only 4 tasks afterwards. So in that, we might have to consider A first. A should be given preference because it has more number of tasks afterwards, and followed by B and C. So both of them, A is considered, we still have time remaining, and B and C can be considered, either one of them can be considered. In that case, maybe we can give more weightage to C because it is taking more task time. So these tiebreakers will be mentioned in the problem, so that has to be considered. So using this, we are considering the idle time. From there, what is the total efficiency of the particular design? Thank you.